All right, morning. So I'm just going to start off by asking if people have any specific questions with regards to what we started looking at last time we met. I don't know if it was yesterday or the day before yesterday or something, can't remember. But we started our discussion of so-called, well, it's lecture series number 12. So for organization and file systems, we're setting the stage for a discussion of so-called computer storage or secondary memory, as they call it, persistent storage. So I don't know if people have any random thoughts about that. Questions that they might, questions that they might have with regards to the same thing. Okay, if there are no questions, then then we will start. Just re-download this thing. Right. There we go. Okay, so we will start. I hope you can hear me, by the way, just to confirm here. I don't want to start speaking to myself. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Great, good stuff. Thank you for confirming. So interestingly enough, we more or less study our discussion of so-called data encoding, although there is a separate there's a separate class or lecture series which is dedicated to that. But of importance was this idea that we raised, the fact that the access to encoded data is facilitated by so-called application software, right? So the only way the CPU will be able to know exactly how it should present output to your screen, right? If the processing that's taking place requires or produces some sort of output to the screen, is if you tell it to use the correct type of instructions, right? And I showcased a number of word examples where I attempted to open a video file, right? An MP4 file using a text editor. Now the computer will do that for you, right? But unfortunately, the output that you're going to see is not what you expect, right? So you see gibberish, things that don't make sense. And so I guess the key takeaway point here is that that process is user-directed. Yes, sir, hi.
I can't see your screen.
Oh, okay. How about that? Yeah, thanks. So we mentioned that, yeah, I don't know where you are here. There are birds tweeting in the background, which is quite nice, I guess. But, right, so this is an interesting notion here, right? Because we are saying that fundamentally, what you see is dictated by the piece of application, right? And so I have a very funny story from last year and the year before, I think. You know, most of the assignments, take-home quizzes that would write would involve students submitting a PDF document, right? So if you don't submit an assignment as a PDF document, obviously, the Moodle won't allow you to upload the file. And so what some people did, yeah, what some people would do is they would, you know, you create your Word document, right? So this is an example Word document, right? You create they'll create their document, right? Like, let me just save this thing. Save it on my root here, example document. And then I'm just going to save this as a, come on, really? Sample document. So I'm also just going to save this as a doc, right? because this is ODT. So what some people would do, right, is you have your Word document, and I guess it's a question of not knowing, right? And so the assumption they were making is that you change the encoding, the data encoding of the file format by simply changing the extension, right? So they'll come to this document, right? And then simply come here and you change this to .pdf. And then you submit this. Now, where is that? Now, the Moodle will allow you to do this. Where's the sample document? I thought I had the sample document here. Okay, .docx. Let me just see if I can find this. Why am I saving this as this thing here? Sorry about that. Now the Moodle will allow you to upload the document, because what it does, it turns out, is that, my goodness, I don't know why this is coming out as this is stupid, right? Sample document. Now, the Moodle will allow you to upload this file, right? Because it turns out that what it does is it just looks at the extension, the part that comes after the period, right? After the period. And so this is how, but it turns out that in actual fact, the encoded data is not in PDF format, right? Observe, if I was to run this utility, right? The file utility on the sample document, what you will notice is that it shows me that this is not, it's not a PDF document, right? You see this part here that comes out, but that comes up afterwards. This is a sign that it's not a PDF document. What you're ideally supposed to see for a PDF document is supposed to show you the type of encoding. So observe, if I run the file utility on an actual PDF document, I guess this document here, you'll notice that it shows me that this is actually a PDF encoded document, right? With a specific version, PDF version, right? Now, if I attempt to open this, and I know Okula will probably open this for me, but if you were to open up a file that was previously a .doc, but changed, still a .doc, but I guess made to look like it's a PDF document by simply changing the extension, your PDF viewer will fail to make sense out of that. Now, it's just that my document viewer, Okula, also is probably able to open, there we go. There we go. You see this? I don't know if you can see this error. Yeah, it's showing it's unable to open this document. Why? Because it can't understand the encoding. Yeah, but what my file explorer is telling me is that if I look at this, the icon itself seems to suggest that it's a PDF document. So key takeaway point here is application is extremely important. You must make sure you're doing the right thing. So if you have a document like this and you're told by your respective lecturer to upload a PDF document, you want to make sure that you convert it the right way, right? You use the correct type of application software, convert it to PDF. Oh my goodness, this machine is slow now. And there are usually inbuilt features for most of these popular web processing packages, like I have to show some of these things here. For most of these popular web packages, like Microsoft Word, and I know LibreOffice Writer, OpenOffice Writer, all these popular, Office or something, all of these popular packages will have a feature that will allow you to export this as PDF, right? So that essentially you're telling the CPU to say you want to re-encode the data in a completely different format, right? So if I export this to something like a PDF correct, and if I run the file utility or the file command on this newly created PDF document, you notice that the encoding is now telling me that this is a PDF document. Yeah, so these are things to really pay particular attention to. Yeah, you always want to make sure you do the correct thing. All right. And this explains why we keep saying that your computer, as far as it's concerned, everything is the same. It's just a stream of ones and zeros, right? The thing that sets apart those ones and zeros from each point of view are the program instructions that you're using to manipulate the data. Yeah, very important point. And then we then started our discussion of files and directories. So distinguishing the fundamental differences between the two main types of files, so regular files and directories. We made mention of the fact that a directory is a unique type of file in that, unlike a regular file that is used to encode the content that the users consume, a directory is a container structure. So it's used to logically organize other files, right? So it could be used to logically organize regular files or indeed other directories. So you can have subdirectories within a directory and subdirectories within a subdirectory and subdirectories within a subdirectory, right? So interesting things. Right, and then we kind of parted ways when I was trying to emphasize, or rather trying to introduce this whole notion of file systems to make mention of the fact that it turns out that there's a limitation as to how many nested directories you can have within a directory, right? It's not like it's you can have an infinite number of subdirectories within a directory hierarchy, right? So as you are creating directories, right? There are example, right? What we're saying is that as you're going in here, 1, 2, right? 3, right? 4. As you're going, there's a limit, right? There's usually a limit with regards to how many levels you can have. It's not like you can have an infinite number of directories, right? There's always a limit. So what we're saying is, observe, if I do a tree here, what we're saying is that this hierarchy here, you can't have an infinite hierarchy going on and on and on. Usually the limit is imposed by the file system. You'd probably have to look up the details of the respective file system that you're using to find out what sort of limitation you have. And I know what you're thinking. You're probably sitting there and you're thinking, who in their right state of mind would want to come up with an infinite number of directory hierarchies like this, right? Well, it turns out that there are certain use cases where you might want to logically organize data like this, right? You might want to organize data like this. I guess we'll go up to 10 or something. I don't know what limit is associated with my specific file system. And I think it's ext4 or something. Let me just confirm. Yes, sir.
So, can software libraries be stored
Yes,
in
sir.
directories? Can software libraries be stored in directories?
Anything can be stored in a directory, yes. So the software library is a file.
All right.
So yes, yeah, can. So I'm using ext4. So I'd have to look up ext4 to find out what sort of limitation is associated with, great question, by the way, what sort of limitation is associated with this particular file system in terms of the hierarchy, right? So if I run the tree command in dir, so I mean, you could go on and on and on here, right? And yeah, so anyway, container structures, right? And really this organization is really dependent on how the user would want to traverse the file system. People have different preferences. I've met very strange people in my short life so far who prefer to put everything on their desktop, right? So you're dumping everything, all your files on the, hey, if it works for you, that's fine. Although it's inefficient, right? It's inefficient because it makes it a lot harder for you to find files. But of course, I mean, these days you can easily search for files, and so it's not so much of a big deal. But what I prefer to do myself is to come up with a logical way of organizing data, right? So I go into my Dropbox folder, and you can literally see that if I go into my work folder and I look at the tree here and just D, you notice that everything is logically organized, right? I can easily find things because I logically organize my file system in such a way that it's easy for me to find things, right? But of course, I mean, it's subjective, right? Some people would argue that maybe putting everything on the desktop is better, right? I want it, please put it on the desktop, right? Can't find it. Okay. Good stuff. And I know this is revision, right? So it turns out that these things we're calling so-called files, right? A logical way of organizing the stream of ones and zeros have certain characteristics associated with them. So metadata is called, right? Descriptive information about the file, auxiliary information about the file. So these include things like the name, right? So every file on the file system must have a name, and it makes sense. You want an easy way of an easy way to find a particular file that you might be interested in. Every file has a size, yeah? A size that determines the relative number of bits, ones and zeros associated with that file. Usually the size, like we said, like most measurables on a computer is represented in bytes, right? And derived versions of bytes, so bytes, kilobytes, megabytes, gigabytes, terabytes, right? Files will also have a specific type tag, right? So a flag that will signal what sort of file it is. Is it a directory? Is it a regular file? What particular data is encoded within that file? A file will also have timestamps associated with it. So things like when the file was created, when the file was last modified, right? These are all important details associated with so-called files. The file will also have details of where it's located. And I'm sure you're sitting there and you're asking yourselves, well, why would it be important to know where the file is located? I don't know why. I don't know. Any ideas why it would be important for us to know where the file is located? If we went to the file, we checked the metadata associated with the file. Why is it important that we have the location, this part here?
In a lot of instances, you would want the location of the file if you want to maybe reference its path if you're doing something with regard to that file. For example, in some situations, if you want to run, maybe you want to run a script at the startup of the machine. If you want an application to start up each and every time, and maybe you're writing a script for that same application or a file, you're going to notice that you have to write a path in order to show the operating system where exactly that is located, because there are a lot of files on the computer system.
Right. I mean, but the key thing, right? I mean, what you're saying and kind of makes sense, does make sense. Yes, it is correct actually. But the key thing here is the last bit which you didn't finish explaining here. The fact that you want to tell the operating system where that file is located, because it turns out that the naming part here is context, right? So I could have the same file name, but in a different location. No, I wouldn't want to put it in templates. I guess I'll put it in directory example. I can put this file in here. I can put it in here. I can put it in here. I can put it in here. Same file, right? The idea of this file name is that it's only unique within a particular directory, a particular directory or container structure, right? So you cannot have two files with the same name in the same location. This is part of the reason why the location is important. Yeah, good stuff. Okay. Copying finished. I don't know what that means. Depending on the operating system that you have, I mean, there's a whole bunch of additional metadata that you might have associated with the file itself. So I know on Linux you also have You also have the last time when the file was accessed, right? So when it was created, when it was accessed, right? The type of the file, the name, right? Gory details like permissions and whatnot. These all fall under what we're calling metadata, right? So just sorry about that. I don't know who sends messages at 8, right? Why? Oh, it's 8. These are all descriptive information that help provide details about the file itself. All right, so just to...
Oh, Dr. Lighton, just on the metadata, is there a limit to the metadata you can provide to a specific file if you want to describe it?
Well, it's contextual. It depends on the operating system, right? So on Linux, obviously, there is a limit, right? But what do you mean by... Wait a minute. What do you mean by is there a limit here, metadata? Limit in terms of what? The number of metadata elements or...
Yes, the number of the data meta elements.
Yeah, so I mean, it depends. I mean, there's certain metadata elements that you're seeing here that you won't see on Windows. So it depends on the type of operating system you're using. Right? Just enough, you just need sufficient information to comprehensively describe the file, right? So usually this is I guess it would be like administrative metadata, right? Things to do with permissions and access. Like if you want controlled access to a particular file, that's administrative metadata. You'd have structural metadata, like where the file is located, for instance. And then you have the descriptive metadata, right? Auxiliary information about the file, telling you a bit more information about the file, things like the name, the type of the file, its size, right? So there is a limit, yes? The limit is typically imposed by the operating system. Yeah, I guess, I don't know. So, please let me know if this revision, if you need clarity on certain portions of this revision session we're having. I know it's revision now, right? Most people are already familiar with this thing. So just tell me to pause if you want me to pause to explain some of these things so that you better understand what we're talking about. So,
Sir,
yes, sir.
Can you kindly elaborate the meaning of metadata?
It's just descriptive information. It's information about information.
Oh, right.
It's auxiliary information that helps you describe an entity. Right? So you have a file. A file has, another way of looking at metadata are the characteristics of a file. Right? Those characteristics will help you describe the file. Just like we could say metadata about you is your height, your skin complexion, your weight or something, maybe your tribe or something, right? They say we must remove the tribe from NRC or something, right? So these are just characteristics or traits about the file, essentially. Textbook definition for metadata is data about data, right? Which is a bit of a misnomer here, but anyway. I hope that answers your question. So a file name does nothing more than we're just going through these different characteristics, right? Metadata elements associated with files in succession here. So file names will help you uniquely identify a file object, right? And usually there are rules that are imposed by the operating system on the naming convention of the file. So there are guidelines, right? Characters that are allowed for you to specify the name. Some characters are not allowed, some characters are allowed. Some characters will imply certain things, like in Linux, for instance. If I create a file called sample hidden file, or if I create a copy of this correct metadata file, and then I start naming it, I rename it with a dot. A dot signals something, right? It signals the fact that I want that file to be hidden. I don't want other people to see that file. And true to that, when somebody is navigating my file system, they will not be able to see that file if I haven't configured my my file manager to show me hidden files. So in fact, when I'm running some of these commands, I would have to use certain flags like the off flag here so that I see the hidden files, right? These files with a dot here are all hidden, right? You want the person, if the file manager hasn't been activated to showcase hidden files, other people won't be able to see this, right? So certain things like certain characters are not allowed to be a part of the name, for instance, right? And so these you'd have to look up to find out specific.
Just a minute.
Yes, sir.
Yeah, so when you hide a file with a dot, does it mean when you yourself you're about to view that file, you're supposed to unhide it?
No, you can view it. So observe, I can't see the file, the thing with the dot here, right? I can't see, and I'm trying to see if let me see if I can find a way of, I don't normally navigate, oh Christ, I don't normally navigate my, my file system using Dolphin, so.
How about Control H?
Oh, let me check if Control H works. Thanks about that. Thanks for that. There we go. Thank you. So somebody knows the shortcut. So Control H in Linux will show you the hidden files, right? There we go. So I can see that, and you can see that it's actually showcased. It looks a bit blurry, right? So file manager is kind of visualizing, showing you that this is a hidden file. Yeah. So you can view this file, but of course you would have to, if you're using a file manager like this, you'd have to unhide it. But if you're using the terminal and you know the type of file, you can open it, right? By just prefixing it with a dot, and then you'll be able to view that file. Great stuff. All right, so the naming, right? The naming is important because it's a way of distinguishing that particular file from the rest of the files on the file system, and more importantly, distinguishing it from other files within that particular directory. And the uniqueness really is contextual, it's relative to a directory. So you cannot have two files with the same name in the same directory, but you can have multiple files with different names if they're located on different parts of the file system. Some operating systems will be case sensitive, some of them will be case insensitive. So for instance, I think Windows is probably one of those weird operating systems which are not case sensitive. I could be wrong. Last time I checked, it was not case sensitive. So if a file like example, a file like case sensitive.txt on Windows would be the same as case sensitive, right? Or uppercase. But in Linux, these are two different files, which is why I can have these two files in the same location, right? Linux views these as different because Linux is case sensitive, right? But these are all things that are specific to operating system that you're using. These are all really design decisions. I mean, perhaps it might make sense in Windows that case sensitivity is not so much of an important requirement, and maybe in Linux it's important anyway. I guess because most novice users would typically use operating systems like Windows, so find it strange that no, but I typed a file. Why are there two files, right, with the same name in there or something? Well, they're different. They have is this the same as this? Huh? Do you remember the alphabet? Is this the same as this? Yeah, and I know what you're thinking, right? Yes, they're the same. They're all A's. Okay, fine. But anyway, so this is contextual. It's related to the operating system. And then there's also size, right? So the size does nothing more than represent the measure or the quantity, the number of bits that have been encoded within that particular file. So it gives you an idea of how many bits you have in the file. And you can actually compute these things if you're handling if you're handling very easy data types, right? So for instance, if you create a file that is exclusively composed of characters, you can easily reduce the size of the file. Observe, if I go into our case insensitive example here, yeah, and I just type in ICT 1110. Each character is 8 bits. So, okay, let's use an example of I. Each character is made up of 8 bits. And so we expect this file, which has one character, an I, to have a size of 1 byte. Now, sorry about that. To have a size of, now I know the 2 here is probably, and I hate this, there's probably some special character here. But ideally, anyway, you can deduce this because you know that a character is mapped onto a specific number of bits, and those bits obviously translate to bytes, and so you can easily compute the size, right? It's 0, 2 here. And the additional 2 here is, there's probably a special character at the end here. I wonder if there's a way of easily creating this. Let me just let me see if I can see. You see this new line here. My text edition uses 2 lines, right? If I just save this and I do an ls to see the number of I guess bytes, you notice that I now have 1, right? Or maybe if I just need to show this, actually, why don't we use a format so that people understand? It's still 2 bytes. It's something I'm not doing right here. But anyway, there's probably some special character here where it's 2 bytes. But you can, the bottom line is you can compute what is inside the file depending on the type of data type that you're working with, right? So size here 2B. It's not very easy for certain types of data like images, because there's so many different things at play here. Things like the type of resolution that you're using, the quality, the resolution, quality of quality used for you to encode that particular image, right? So, but for text, obviously, it's much easier to do that. Right, and usually it decides to exclude the metadata, obviously. Your operating system will typically represent the measurable, the size of the file, either in bytes, kilobytes, megabytes, gigabytes, or terabytes. It's depending on how much of data you have encoded in that particular file, right? So if I was to use my file manager to check the properties of this, you notice the size is automatically presented to me by default in gigabytes, because my file manager, my operating system, knows that this is a relatively large file. But of course, in parentheses here you have the equivalent number of bytes, right? If I open a relatively smaller file, this is like 116 kilobytes, and I do properties, you notice that it's represented in kilobytes, right? KB. In parentheses, you have the number of bytes, right? So the type will typically show you the specific type of the file. It's a bit recursive here, whether it's a regular file or it's a directory. And more specifically, if it's a regular file, the specific type of the regular file, you know. So is it a symbolic link, for instance? Is it a normal regular file? So if you're in Windows, is it a shortcut? And you see, for certain file managers on certain types of operating systems, you have further auxiliary information like the specific data that's encoded. If you look at type here, my file manager is telling me, Dolphin is telling me that this is an image, a specific type of image file. It's a PNG file, right? If I open, if I was to convert this to a different type of image format, let's say JPEG. I'll also convert this to EPS and also convert this to XBF or something. What you immediately notice is that if I try and check the properties of these things, I get the type changes, right? They are all images, but specific. The file manager is telling me the specific type of image, how it's encoded. So GIF or GIF, depending on where you're coming from, EPS, JPEG, right? And then finally PNG.
Oh, Dr. Lighton, just there, you mentioned about a symbolic link. What exactly is meant by a symbolic link in
It's a
Linux
shortcut.
OS?
It's a shortcut.
Oh,
It's just a
right, thank
shortcut. It's a reference to an already existing file. So the thing, right? It's something to think about here. So I'm just going to give you a short usage scenario. What I do, right? Since I joined the UNZA, I guess since I started teaching this course, 2018, right? In 2018, when I'm teaching this course, it's so-called ICT 1110, there are certain things that are common, right? Like resources that I use. So, and I pay attention, please. If I was to, and I'm going to showcase this because it was stupid of me to do this. I'm going to showcase something to you. If I can just find what I'm looking for. No, actually, I'm just going to make text this, I guess. So this has become somewhat of it's one of the textbooks we use. It's an it's an open source textbook that we use, right? When we're dealing with the second part of the course, it's a computer architecture part of the course. But if I'm using this piece of text every year, right? And if I organize my directory hierarchy in years like so, well, this is not if, but this is how I do this. It's stupid, right, for me to copy across that textbook over and over again in 2019, 2020, hopefully I'll still be alive in 2021 and 2022, just copying it across. The reason it's stupid is because I'm using up space, and space is a premium, right? Space is a premium, especially for those of, I guess for me anyway, because sometimes I'll use Dropbox to synchronize this content, and so I want to make sure that I carefully make use of my space. What would be smart is for me to create a symbolic link, right, of this particular textbook itself. So I would come to 2020, come into ICT 1110, and then come under resources, and then under resources, what I would do is I would just say, I want to create a symbolic link that's going to point to Dropbox document. That's going to point to this textbook, right? And I want to create it here. So that when I have this thing here, you notice that this thing here has this size, right? 2.4 megabytes. Creating a shortcut or a symbolic link means that I won't be able to waste 2.4 megabytes of space on my Dropbox account. It's not a big deal on my machine itself because I have plenty of space. It's a big deal on Dropbox. Why? Because my Dropbox account, I have the free tier account, right? Hopefully I'll be able to, this year I do plan to, I hope I have a lot more space here when I send referral links to you guys. But my Dropbox account has a limitation. And so I have to be very careful how I'm using up space. I have to be very strategic in how I use up space, right? Because my plan, come on, my plan, show me. my plan has a limit. You know, so I want to be very careful about this part here, seeing here. All right, so that's that about shortcuts, right? I hope that answers your question. Anyway,
thank you very much.
yeah, right. Right. So there's also timestamps, right? Very important attribute. So a timestamp will be a composite of sometimes called Unix timestamp here, composite of the time and the date, right? So details of when exactly that particular file was created. This is, it might be important in instances where auditing might be important, for instance, like perhaps let's assuming that each one of you guys would have a separate record. UZA has a separate record for each one of you guys. You want a way to be able to tell when your record changed, right? Audit trails are very important for certain use cases, right? So that if something untoward happens, as we've heard sometimes when the grades are changed and whatnot, you want to be able to tell when was the change made, by whom, right? When was this particular file created? When was it last modified? And in certain instances, these are actually important on applications that we use on a day-to-day basis, like the Moodle, for instance. I don't know if you've noticed, but when we are uploading resources on the Moodle, these details, meta information about the files are presented to you. I don't know if you've noticed this. If you pay particular attention, what I've done is I've activated or I've configured the site in such a way that when we upload regular files like PDF documents and those chat transcripts, the TXT files, we tell you when the file was last modified, so that as you are consuming these resources, when you come here and you realize, oh, this guy Lighton changed, the date he has changed, so meaning that he has updated the slides, right? This is a meta information about the slide, showing you exactly when this file was uploaded or something. Right? Anyway, so I mentioned it's a timestamp. And then there's the location, right? So like somebody already told us, just tells us where exactly the file is on the file system. File system can be quite massive, right? If I was to go to the root of my file system, which is where I'm at right now, you notice that the high-level root here has these directories, but as soon as I start running the tree command, it's wild out here, right? It's a messy place, and so you need a way of identifying exactly where particular files are located, right? So that you can easily find them. Location, location, location. Now, for some users, I mean, their file system is probably very simple. You create, the C drive, I'll start putting my files on the C drive or on my desktop, right? Not so complex, so maybe location is not so very important because as far as you're concerned, everything is on the desktop, that's fine. But in certain instances, for certain types of computer systems or certain applications, the location is very important. Location of where a particular application is located. Where did you install the file server? Where is it installed, right? Where are the actual HTML documents of where is the, where are the HTML files associated with the web application located, right? Oh, they're in var HTML, www HTML, they're in this location. You will be able to find them here. Just navigate to this location. Sorry, navigate to this location, right? Navigate to this location. Location, 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 right? Again, there's certain things to do with the length of the location. This is normally imposed by your file system, right? So what we're saying is that the length of this file path here, this is to do with the hierarchy itself. It turns out that there's a limitation associated with this path. Yeah, so if we were to go back to that example where we had a directory example here and go down this hierarchy, location of this hierarchy is here. this is normally imposed by the length, the number of characters that are expected in this length, this file path here. There's a limitation. Most file systems, if not all of them, have a limitation. You can't have 2 million characters representing a file path. Maybe you can for some file systems, but there's a limit, right? Is this making sense?
Yes, sir.
Yeah, right. Okay. Right, so I mean, that was a kind of a short rant about, I guess, a short walkthrough about the different, remember, different metadata or characteristics associated with files. This by no means comprehensive, but some of the most common characteristics that you find on different operating systems. You find these on Android as well. Android is a Unix-like operating system, so the things that you're looking at here, you will find on Android anyways. I'm looking at the time, and I was going to say we do a walkthrough, but we'll continue this walkthrough on, I don't know if it's Monday or something. We can do a walkthrough. I don't know if we can do a walkthrough. Yeah, I don't know about that, but we'll continue with the walkthrough on Monday, and then immediately we're done with the walkthrough. I don't know if it's Monday or Tuesday or something, I don't know. Immediately we're done with that, we shall start looking at file operations, and then I hope we can finish, I don't know. I hope we can finish this by next week so that we can immediately jump on to secondary storage, after which we can then transition to the next part of the course, right? Unless if there are any specific questions, I do encourage you guys to please play around with your Android phones. Part of the reason why we use the Unix file system as a case study is because you can easily relate to it. How? The average smartphone that you have in your hand here, if you're running an Android-powered smartphone, it runs off a Linux operating system. It's a Unix-like operating system. So we do this because we know that you have access to a computer system, a smartphone that you can use to play around with. I do encourage you to play around with some of these things. I don't know if you've already looked into Android debug mode. If you feel like being adventurous, you can look into that. But if not, you can use the default file manager to just try and look at these different characteristics. Great. So I don't know if there are any questions. If not, then I will see you when you see me, I suppose. I don't know. Any questions? Okay, thanks. Okay,
Sir,
thank you.
Oh, sir, I think I've got a question.
Yes, sir.
Will there be any quizzes regarding these topics we are doing now, or it's only going to be till we meet?
Yes, there will be quizzes.
Right. Thank you.
Somebody else had a question.
So all these topics that we've done from like topic 11 up to now, all this is it under primary storage only? Is it minus secondary storage, or maybe something like that? I'm a bit confused there.
Well, we are lecture series number 12 is secondary storage. The previous lecture series, which was 11, was primary storage. This is supposed to be part of secondary storage, because so lecture series number 12 is associated with secondary storage because the things that we store on secondary storage have to be logically organized in a certain way. When you're persistently storing something on a storage medium, it has to be organized in a certain way. The logical organization is in the form of files. Those files will find themselves on a file system. So before we start looking at specific details associated with secondary storage devices and secondary storage mediums, we are having a conversation around this logical organization of files. Lecture series number 11 was primary storage. Now, this is the part now where I said you have to be very careful how you organize your files because I don't dump everything on my, guys, look at my, my desktop is clean, right? You should be organized in life like I am, right? Not messy, yeah, clean. This is life here. So lecture series number 11, I'm flexing now, I'm up there, I'm putting myself on a pedestal, and it is clean actually. So lecture series number 11 was primary memory. Lecture series number 12 is secondary memory. Lecture series number 13 is going to be still secondary memory or computer storage. Any other questions? Stay safe. See you when you see me. Bye-bye.
Guys, how's it going?